Introducing LEANTOOL, the standardized tooling system from Byler that revolutionizes stamping and forming. With LEANTOOL, new tools for sheet metal or wire processing become easier, faster, and significantly more cost-effective than traditional toolmaking. LEANTOOL provides a kit-based modular tooling platform. More than 70% of the necessary parts are standardized. This allows tool designers to assemble or reconfigure tools rapidly without bespoke fabrication for every new part. Thanks to this standardization, the time and cost to produce new tools can drop dramatically, often by up to 70% compared with conventional progressive or radial tools. With LEANTOOL, the steps from planning and design through manufacturing, assembly, setup, and production become highly streamlined. Because the tooling is modular and machine-ready, setup times are short, and once installed on a compatible Byler servo stamping or forming machine, like RMNC or GRMNC, production can start quickly with high repeatability. The flexibility of LEANTOOL makes it ideal for a wide range of applications, from simple stamped parts to complex formed components in sectors like automotive, electrical, household goods, or industrial equipment. Welcome to the production floor at Dodi GmbH, where the Byler BIMERI CBM 4500, a modular servo production and assembly system, illustrates the future of flexible manufacturing. Designed for high efficiency, adaptability, and precision, BIMERIC handles stamping, forming, feeding, welding, assembly, and more within a single integrated platform. BIMERIC is built around a modular base. Individual process modules, feeding, stamping, forming, servo presses, welding, thread forming, pick and place, are combined as needed, depending on the product or assembly line requirements. This modular architecture makes it ideal for small to medium batch sizes and high variant diversity, where frequent changeovers are needed. Thanks to standardized tool interfaces, up to 70% shared tool parts, tool changeover and setup times are dramatically reduced. Bimeric supports fast, reproducible setup. Depending on configuration, the system supports stamping presses up to 400 kilonewtons, servo forming units, and material feed of strip up to 80 mm width, or wire up to 4 mm, enabling fabrication from sheet, strip, or wire. The servo drive and NC-controlled modules allow highly flexible motion, stamping, bending, forming, welding, tapping, assembly, pick and place, all in one line. Stroke rates, where applicable, reach up to 250 strokes per minute, and the system's control center, the central control system, VeriControl VC1, manages all modules, axes, feeds, and quality control. At Dodi, the BIMERIC BM 4500 is leveraged to produce assemblies where multiple fabrication steps, stamping, bending, forming, welding, assembly, are consolidated into a single production flow. This reduces handling, logistics, and intermediate storage. For small and medium series production with many variants, BIMERIC offers a competitive advantage: fast setup, flexible production planning, reduced tooling overhead, and high automation, making short-run assemblies economically viable. From precision coil springs to robust compression, extension, and bending springs, Gute Kunstfedern manufactures every type of spring required across modern industry. Whether extremely resilient or standard grade, whether miniature or large scale, each spring is produced with absolute consistency and quality. Production begins in a vast raw material warehouse holding over 1,000 wire diameters and alloy types. From here, the manufacturing sequence generally includes winding, forming, tempering, grinding, and setting tailored to the specific spring type. For larger compression springs, the FSE 83 winding system handles wire diameters from 4 to 12 millimeters. Cylindrical, conical, or barrel-shaped springs can all be produced reliably at high throughput. For fine wire production, the 8BCX automatic system includes an optical measurement unit. Each spring is checked 100% for pitch accuracy, outer diameter, and length, and any part outside tolerance is automatically rejected to maintain perfect consistency. The ZO23 system supports variable hook shapes and controlled body expansion. This next-generation platform produces fully finished extension springs without any manual intervention, again with complete optical measurement. For shaped wire components, the USFP-C4 CNC bending machine forms complex geometries from wire up to 4 mm thick. A built-in laser scanning system verifies dimensional accuracy immediately after bending. Grinding of compression spring ends is handled by automated DR54 grinding stations. Springs are loaded, ground, checked, and unloaded in one continuous cycle, ensuring flawless perpendicularity and surface finish. In a modern metalworking shop, CNC tube bending transforms straight metal pipes into precisely curved shapes with speed and repeatable accuracy. A CNC tube bender uses computer-controlled servo or hydraulic drives, combined with pre-programmed bend parameters, to clamp, rotate, and form tubes to exact angles and radii. Depending on the tooling, mandrel, bending die, clamp, and pressure die, the machine can bend stainless steel, aluminum, or even custom alloys without collapsing, wrinkling, or deforming the tube cross-section. Such machines are widely used in automotive frames, aviation tubing, construction scaffolding, furniture frames, HVAC systems, and any application requiring precise, repeatable curves and metal tubes. CNC tube coiling machines bring a new level of precision and repeatability to tube forming. Using computer-controlled motions, these systems bend and coil metal tubes according to exact specifications, minimizing waste and maximizing consistency. The process begins with a straight tube or pipe fed into the machine. Through a combination of programmed rollers or mandrels, the tube is gradually bent or coiled into the target shape, whether a tight spiral, curved arc, or custom profile. The CNC control ensures each bend is identical, ideal for serial production or complex geometries. Thanks to this automation, manufacturers can reliably produce components for industries like HVAC, automotive exhaust systems, structural frames, or industrial equipment, wherever bent or coiled tubes are needed. This is Coral Mill Plura HD, a high-performance solid carbide in-mill engineered for heavy-duty milling in steel and stainless steel. It's quick, becoming the first choice when reliability, cutting speed, and tool life matter. Coral Mill Plura HD achieves exceptional metal removal rates thanks to its optimized flute design, helping chips evacuate efficiently and reducing heat buildup during deep cuts. With the latest Zertivo 2.0 coating, the tool delivers superior durability and process security even under demanding conditions. It supports operations like shoulder milling, full slot roughing up to 2x D depth, ramping, and helical interpolation, making it versatile for a broad range of tough milling jobs. For manufacturers working with alloy steel, structural components, or stainless parts, Coral Mill Plura HD brings speed, consistency, and long tool life. Here we dive into the production of serpentine-shaped tubes, the backbone of many heat exchangers, boilers, and industrial piping systems. A serpentine tube, a metal pipe bent into repeated curves or coils, provides efficient fluid flow and maximum heat exchange in compact spaces. Serpentine tubes excel because their continuous bent shape increases the effective surface area while reducing the number of joints, minimizing leak risks and enhancing durability. They're widely used in refrigeration units, boilers, condensers, heating systems, and other heat exchange applications, wherever efficient heat transfer matters. In modern factories, CNC-controlled machines feed straight metal tubing and bend it into precise serpentine coils. The bending process uses servo or hydraulic drives, mandrels or dies, to ensure smooth curves, accurate radii, and no deformation of the tube cross-section. Automation ensures repeatable geometry, consistent bending angles, and fast production, converting raw straight tubes into ready-to-use serpentine coils in seconds. After bending, each tube is inspected for uniformity, wall thickness, and smoothness, critical in applications where fluid tightness and pressure resistance matter. The resulting coils are used in boilers, HVAC units, industrial heat exchangers, and many other systems requiring efficient fluid flow and reliable performance.